Okay, good morning everyone. Today we're moving on to section 8.6, radical expression and rational exponents, or rational exponents. And so before I actually get into today's lesson, let me just review something with you. All right, this will be rational exponents. So what's a radical expression? Well, we've worked with these in the past. So for example, something like the square root of 15. That would be a radical expression, a radical 15. The rational exponent, if you remember, I told you this before, anytime you take the square root of a number, that's like taking 15 raised to the 1/2, so that would be the rational exponent. We would say the square root of 15 in terms of rational exponents is 15 raised to 1/2. Exponents being some base raised to an exponent, so the exponent being 1/2. So that would be the rational exponent form, and then this would be the radical form. All right, so we're going to be working between the two, going back and forth, if you will, from rational exponents to radical expressions or vice versa. And then we'll simplify and evaluate radical expressions and expressions containing rational exponents. So vocab, index, and then rational exponents. So let's go through this. You're probably familiar with finding the square root of a number. Okay, these two operations are inverses of each other. Similarly, there are roots that correspond to larger powers. So we would say, so for example, if I had the square root of 25, you would say that's equal to 5, or it could also be equal to -5. Okay, 5 squared is equal to 25, but -5 squared equals 25 as well. Okay, so we would say 5 and -5 are square roots of 25. 2 is the cube root of 8 because 2 to the third is equal to 8. Now, how would we write that in terms of radical expression? Well, we would write that the cube root of 8 is equal to 2. So that would be the radical expression. Okay. 2 is the cube root of 8 because 2 to the third is 8. 2 and -2 are the fourth root of 16 because 2 to the fourth is 16. So in terms of radical expressions, we would say the fourth root of 16. The fourth root of 16 is equal to 2 because 2 to the fourth is equal to 16, but it could also equal -2 because -2 to the fourth equals 16. And so we say A is the nth root of B if A raised to the n is equal to B. In other words, 2 here is the fourth root of 16 because 2 to the 4 equals 16. The nth root of a real number can be written as a radical expression, the nth root of A, where n is the index of the radical and A is the radicand. So in this example here, n was equal to 4, so that was the index. And then A is 16 was the radicand. So the fourth root of 16 equals 2 because 2 to the fourth equals 16. Here the index was 3. The radicand was 8. So we're taking the cube root of 8 is equal to 2. The expression, the nth root of A, really says this: what number multiplied by itself n times gives you A? So 2 multiplied by itself 4 times gives you 16. Okay, so the fourth root of 16 equals 2. What number multiplied by itself 4 times gives you 16? Well, that is 2. Okay, so when a radical sign shows no index, it represents the square root. And we've worked with square roots before. So square root of 36 equals 6. Square root of 36 is equal to 6. Or it could also equal -6 as well, because -6 squared is equal to 36, and 6 squared is equal to 36. Now, You can take the odd root of a negative number. So for example, if I said the cube root of negative 8, well, that would equal negative 2, because negative 2 multiplied by itself 3 times would give you negative 2. You can take the odd root of a negative number, but you can't take the even root of a negative number. So for example, if I said the fourth root of negative 16, well, what number multiplied by itself 4 times gives you negative 16? There is no number. Okay, you take a number and multiply it by itself 4 times, you will get a positive. So this, you can never take the even root of a negative number, but you can take the odd root of a negative number. So let's look at some more examples. Find all the real roots. The sixth root of 64, so we would write that. The sixth root of 64 equals 2, because 2 multiplied by itself 6 times is 64, but it could also equal negative 2, because negative 2 multiplied by itself 6 times would give you 64. The cube root of negative 216. So the cube root of negative 216, well, that will equal negative 6, because negative 6 raised to the third will equal negative 216. And here, the fourth root of negative 1024 does not exist. You can't take the even root of a negative number. It does not exist. The fourth root of negative 256, again, does not exist. The fourth root of negative 256 does not exist. You can't take the even root of a negative number. The sixth root of 1. Well, now that would just equal 1, or it could equal negative 1. Because negative 1 multiplied by itself 6 times gives you 1, and 1 multiplied by itself 6 times gives you 1. The cube root of 125, well, that will equal 5. Okay. So again, we call these the radical expression. The radical expression. Oh, that one there, that would not be possible. A rational exponent is an exponent that can be expressed as m divided by n. In other words, we have a fraction for exponent where m and n are integers and n not equal to 0. We can't divide by 0. Radical expressions can be written by using rational exponents. Okay, so as I mentioned before, if I said the square root of 15, I said before, well, that's equal to 15 raised to 1/2. This is the radical expression, and this is the rational exponents. And so we have this rule, it says this, that a raised to the 1 over n is equal to the nth root of a. So 15 raised to 1/2 is equal to the square root of 15. And again, we don't write the index 2. We don't write the index 2 when we write the square root. So a raised to the 1 over n is equal to the nth root of a. 16 raised to the 1/4 means the fourth root of 16. The fourth root of 16 equals 2. And then we can also write it this. We can say a raised to the m over n is equal to, there's two ways we can write this. We could say it's equal to the nth root of a and then raise everything to the m, or it's equal to the nth root of a to the m. Okay, so sometimes you want to work with this form, and sometimes you want to work with this form. So for example, they give us that 8 raised to 2/3, that's the cube root of 8 squared. The cube root of 8 is 2, and 2 squared is 4. But I could have just as well said this was equal to the cube root of 8 squared, which is the cube root of 64, which equals 4. Okay. Either one would have been fine, except sometimes it's much easier to work with this form than the other one. The denominator of the rational exponent becomes the index of the radical, as you saw there. So the 3 became the index. The 4 here, the denominator became the index. Write the expression negative 32 raised to 3/4 in radical form and simplify. Okay, so negative 32 raised to the 3/5, that would, we can write it as the 5th root of negative 32 raised to the 3rd. The 5th root of negative 32 is negative 2, and negative 2 to the 3rd gives you negative 8. Or we could write it the 5th root of negative 32 to the 3rd. Negative 32 to the 3rd gives you negative 32768, which equals negative 8. As you will see, this here, this form, though, is much easier to evaluate than this form here, because after all, who would know what's the 5th root of negative 3268? Write the expression in radical form and simplify. So again, 4 raised to the 5/2. So we can write that, and that's the square root of 4 raised to the 5th. So the square root of 4 raised to the 5th, the square root of 4 is 2, and 2 to the 5th is 32. Or we can write it, the square root of 4 raised to the 5th, well, 4 to the 5th is 1024, but now, do you know the square root of 1024? It's still 32. Again, like I say, sometimes this form is much easier to work with. All right, let's continue. Write the expression 625 raised to 3/4 in radical form. Okay, so again, we're talking about the 4th root of 625, and then we're going to take our answer and cube it. 4th root of 625 is 5, and 5 cubed is 125. But then if I go the 4th root of 625 cubed is 244140625. And who knows what the 4th root of that is? Well, it's going to be 125. But you'll see, again, method 1 is a lot easier to work with. When simplifying radicals, simplify as you would in simplifying square roots. Find the largest nth root factor. Okay, so the properties of square roots in lesson 1.3 also applies to nth root. So here we have this property that the nth root of a times b is equal to the nth root of a times the nth root of b. If you recall, when we simplify radicals, so for example, if I had radical 32, you want to find the largest nth root factor. Well, I want to find the largest square root factor. Largest factor of 32, that's a perfect square. That's 16, so I could write that the square root of 16 times the square root of 2. Square root of 16 is 4, so that would be 4 root 2. Or if I had the square root of 75. The largest perfect number that's a factor of 75 is 25, so that would be the square root of 25 times the square root of 3, which is 5 root 3. Okay. So that's all that says, that the nth root of a times b is equal to the nth root of a times the nth root of b. And then we have the quotient property of roots, that the nth root of a over b is equal to the nth root of a divided by the nth root of b. So again, if I had the square root of 81 over 25, that would be the square root of 81 over the square root of 25, and that will equal, square root of 81 is 9, the square root of 25 is 5, so 9/5. So let's look at simplifying radical expressions. So here we have 4, the 4th root of 81, and then times x to the 12. With variables, okay, with variables, when you're working with variables and radical expressions, you always want to find, so for example, I have the 4th root of x to the 12th. Okay, so my index is 4. What I want to do is I want to find the largest multiple of 4 of that exponent. Okay? Well, 4 is a multiple of 12. So and again, in terms of rational exponents, that's a radical expression, but in terms of rational exponents, that would be x raised to 12 over 4, which is 3. So this would be x to the 3rd. X to the 3rd. The 4th root of x to the 12th would be x to the 3rd. So this would equal x to the third, or x to 12 over 4 equals x to the third. But what happens if I had like the fourth root of x to the 15th? Okay, again, I still want to find the largest multiple of 4 that can go into 15. Well, that's 12. Okay, so 4 times 3 is 12. So I could write this here then, the fourth root of x raised to 12 times the fourth root of x to the third. Okay, when I multiply 12 plus 3 gives me 15. Now, why did I write it that way? The fourth root of x to 12 times the fourth root of x to the third. Because 4 is a multiple of 12. It wasn't a multiple of 15, okay? But it is a multiple of 12. And so 12 divided by 4 would be, so this would be x to the third. So this would be x to the third. And then just times 4, the fourth root of x to the third. Final answer, simplified. All right, so here, so the way they did it though, they broke up the x to the 12 into x to the fourth 3 times. So x to the fourth root of x to the fourth, the fourth root of x to the fourth, the fourth root of x to the fourth. And why did they do that? Because 4 is a multiple of 4. 4 is a multiple of 4. The fourth root of x to the fourth is just x. Okay, and so x times x is x cubed. And then the fourth root of 81 is 3. So the fourth root of 81x to the 12th is 3x cubed. Okay. Let's look at the next. Here I have the cube root of 16x to the 7th. So I would ask myself, what's the largest cube factor of 16? Well, that would be 8. Okay, that would be 8. So the largest cube factor of 16 is 8. So I would write this 3 times 8, because I know that the cube root of 8 is 2. And then what's the largest multiple of 3 that would go into 7? Well, it's 6. So I would write this x to the 6 times the cube root. Well, 8 times 2 is 16. And then I'd have an x left over. So 6 and 1, well, that will give me x to the 7th. Now again, why did I write x to the 6th? Because I can take 6 and divide it by 3. In other words, 3 is a multiple of 6, but it was not a multiple of 7. Okay, so I just broke it up. And then I can evaluate this. The cube root of 8 is 2. And then 6 divided by 3 is 2, so this would be 2x squared times the cube root of 2x. Let's look at the next one, the cube root of negative 32x squared. So again, I would ask myself, what's the largest perfect cube factor of 32? So I'm thinking, okay, 2 times 2 times 2 is 8. Well, 8 times 4 is 32, so it's going to be 8. So this is going to be 3. But I'll write that negative 8. Okay, negative 8, because why did I write it negative 8? Because I have an odd index. So negative 8. And then, so that would be the cube root of negative 8. And then what's left over would be the cube root. Well, I need 4, because 4 times negative 8 gives me negative 32, and then an x squared. All right, and so this would then equal, the cube root of negative 8 would be negative 2, and then times 3 times 4x squared. Now, again, I could not have evaluated, so if I had the cube root of x squared, there's nothing I can do with that. Okay, the exponent 2 is less than the index 3. There's no multiple of 3 that goes into 2. So I leave my final answer that way. And then finally here, I'm the fourth root of 48 times x to the eighth. Well, again, I'm thinking, what's the largest perfect fourth root factor of 48? So I go 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 3 is 48. So I would write this the fourth root of 16. And then x to the eighth. Why? Because 4 is a multiple of 8. And then I would have left over the fourth root of 3, because 16 times 3 is 48. So the fourth root of 16 is 2. And 8 divided by 4 would be 2. So this would be x squared. And then times the fourth root of 3 left over. Okay, so that was simplifying radicals. Now we'll look at rationalizing the denominator. So to recall, to rationalize the denominator, you want to get rid of the radical in the denominator. So I have 5 over root 2, so I need to multiply this by root 2 times root 2. You multiply both the numerator and denominator by the radical on the denominator. And so that would give me then a 5 root 2. Root 2 times root 2 would be root 4, but that would equal 5 root 2 over 2. Done. Rationalize. And again, I'm just reviewing this here with you. And then if I have the square root of 3 over the square root of 5, again, I want to rationalize the denominator. I'd multiply that by root 5 and then times root 5. And then that would be 3 root 5. Root 5 times root 5 is root 25. And that would be 3 root 5 over 5. Oops, root 15, I'm sorry. 3 times 5 is 15. Wait a minute. So root 3 times root 5 is root 15. My bad. Root 3 times root 5 is root 15. Okay, over 5. Yeah, and don't make the mistake of trying to take 15 and divide it by 5. You can't do that, okay, because 1 is a radical and 1 is not, okay? So don't make the mistake of doing this here. That's a no-no. Can't do that. Why? Because 5 is not radical 5. You can only divide a radical by a radical. All right, and then here, now let's look at these. So here, if I have 5 divided by the cube root of 2, the cube root of 2. The easiest thing to do is to write this radical expression as a rational exponent. So this will equal 5 over 3, or 2, raised to the 1/3. Again, remember that the nth root, what did we say up here? If I go back up here, let's look at what they said here. Okay, a raised to the 1 over n is equal to the nth root of a. So let me go back here. Or a raised to the m over n is equal to the nth root of a raised to the m, or is equal to the nth root of a raised to the m. Okay, so here I have the cube root of 2. Well, that's the same as 2 raised to the 1/3. 2 raised to the 1/3. The cube root of 2 is the same as 2 raised to 1/3. So I went from radical to rational. I still want to rationalize the denominator. So what I can do, I can just multiply this by 2 raised to 2/3. Because when you multiply powers, you add the exponents, and 1/3 plus 2/3 is 3/3. And I'll multiply this by 2 raised to 2/3. So this is going to equal then, so 2 raised to 1/3 times 2 raised to 2/3, that's just 2 raised to 1, it's just 2. But then I'll have 5 times 2 raised to 2/3. But that will equal 5, so the cube root of 2 squared, which is 4 over 2. Okay, it's very important to keep these rules in mind. A raised to the m over n is equal to the nth root of a raised to the m, or the nth root of a raised, the nth root of a and then raise everything to the m, or the nth root of a raised to the m. Let's work through some more of these. So for example, I have the cube root of 5 over x cubed. I can write this here as a cube root of 5 divided by the cube root of x cubed, and that's just going to equal the cube root of 5. The cube root of x cubed is just x, so done. Let's look at the next one, the cube root of 8x to the 9th over 7, so I can write this as a cube root of 8x raised to the 9th over the cube root of 7. And so this will equal, if I simplify this, the cube root of 8 is 2, so this will be 2, and then 9 divided by 3 is 3, so this would be 2x to the 3rd. The cube root of 8 is 2, and then 9 divided by 3 is 3. And then I'll write this as a rational exponent. The cube root of 7, that's the same as 7 raised to 1/3. And then now I'll multiply this by 7 raised to 2/3. And then what will that give me? So that will give me 2x cubed. 7 raised to the 2/3 is the same as a cube root of 7 squared, which is 49 all over 7. And again, I'm just converting 7 raised to 2/3 as the third root of 7 squared, which is 49. And then finally, I have the cube root of 16x squared over the cube root of 3. So I'll work with the numerator first. So this is going to be the cube root of 16x squared over the cube root of 3. And I can write this as the largest perfect cube factor of 16 is 8. So I'll write this the cube root of 8. And then times the cube root of x squared. 2x squared, because 2 times 8 is 16. 2 times 8 is 16. And then I have my x squared. Okay, and the all over, I'll write this as a rational exponent. This would be 3 raised to 1/3. I'll simplify my numerator. I'll simplify my numerator first. I can write this, then the cube root of 8 is 2 times 3 times the cube root of 2x squared over 3 raised to 1/3. And let me just rewrite that. So I have 2 times the cube root of 2x squared over 3 raised to 1/3. And now if I multiply by 3 raised to 2/3, because 1/3 plus 2/3 is 3/3. Let me clear that up. That's 2/3. Okay, so what will that give me? That will give me 2 times 3, the cube root. I'm working with the cube root of 2x squared times the cube root of 3 squared is 9. Again, I converted 3 raised to 2/3 as the cube root of 3 squared, which is the cube root of 3, the cube root of 9, and then this is all over 3, and then finally I'll multiply. And because my indexes are the same, I'll multiply the 2 and the 9. So I'll get 2 times the cube root. 2 times 9 is 18. 18x squared over 3. Done. Okay, so that's an introduction into working with rational exponents and radical expressions and being able to go back and forth between the two.